Hi, so I'm Rudolf. I write at sourcecontribute.com. It's open source blogging, never Fridays, generic comp sci, software engineering, everything. It's my blog for many, many years, and I'm also currently a senior software developer at Zynga. So this talk is basically about the Zen of Python, and I call it a philosophy because it kind of is, and it influences how you write code in other languages as well. So I'm going to begin with going over PEP 20, the Zen of Python, and then looking at Jupyter notebooks and Sphinx, which have been mentioned a few times here already, and exactly how they embody the philosophy of Python and the Zen of Python specifically. And then I am going to look at moving Python philosophy into JavaScript and Ruby, and JavaScript not so much, Ruby a little bit more. So for those unfamiliar with PEP 20, PEP means Python Enhancement Proposal, and this is one of the earlier ones. I'm sure everybody's familiar with PEP 8, which is the style guide, Python style guide. So PEP 20 is the Zen of Python, and it was written by Tim Peters. And I'm not going to read the whole thing. I'm just going to leave it up. But I did want to point out a few of them that I will be referring to later on. The first one is beautiful is better than ugly. That's kind of a mathematical thing as well, like seeing a nice equation or seeing a nice small program where every part of it makes sense, and just any other solution would actually be kind of ugly. The other line here that I like is explicit is better than implicit. Readability counts. That's a really, really important one, and having it codified and explicitly stated rather than implicitly stated is also very nice. If the implementation is hard to explain, it's a bad idea. So, if you're having a conversation with someone and it's very difficult to explain something, then maybe you need to try a new tack. If the implementation is easy to explain, it may be a good idea. So the expression, embodiment, and enablement of the Python philosophy. So in the real world, we're going to take a look at Jupyter notebooks and Sphinx documentation. And we're going to start with Jupyter. So this used to be called IPython notebooks, and I'm not sure how long ago they changed the name, but they had to change it because it turns out the idea of these notebooks is a really good way to explain how you solve particular problems or how you visualize certain pieces of data and things like that. So for those unfamiliar, Jupyter looks like this. Notebooks look like this. You can embed widgets. You can embed a whole bunch of range of charts. You can embed code. It gets executed. You see the result of that code. So it has a space for explanation. And in particular, again, it embodies like readability counts. If you have a line of code there and there's no explanation, it's not very readable. Or if there's like too much explanation as well as a problem, you got to make it simpler potentially. Explicit is better than implicit is probably the biggest one here, where it's a line of code or a few lines of code and all of a sudden there's a chart like magic. That doesn't really make sense. And you need to explain why that chart is the way it is. And this is a snippet from Peter Norwig's IPython Jupyter notebook. So you can look it up on his GitHub. I'll post the link later for that. And basically, he walks through a bunch of, I think there's 15 plus different problems that he walks through. And you can see step by step how he explains like the solution to the problem, but also as he is developing the solution and what potential missteps he has. Of course, it's cleaned up after the fact. But here you have like, okay, I'm plotting a potential solution for this problem. And this is how it looks like. And then I would like to show a smaller chart of it as well. So again, he's showing it step by step rather than just jumping to the small chart. So you can see clearly here's how I began, and it's a big chart, but actually I'm interested in only this range of numbers, so let me just make it a little smaller. And so this is a snippet that you can use yourself somewhere else, right? So this is, again, explicit is better than implicit, because he could have just jumped to, here's the end result, here's the final result of my solution to this problem, and instead he's going through a step-by-step. So again, this is the same solution as the previous slide. And here you can see much more explanation. There's some links, there's a math equation or two, some limits, and then an explanation of different approaches to problem solving as well. So you can have a really good explanation of why you're doing what you're doing. So you can, instead of having this implication, you're making it explicit in the explanation. And this is actually very, very useful. A lot of times, if you're on a DevOps team of any kind, or something is messed up, you always have like a retrospective or postmortem. And I've thought about it in the last few months. There's things like PagerDuty, and you have a nice template to fill in and everything else like that. But as you're doing that, I've noticed a lot of people take screenshots. So they take screenshots of different slides. They have little explanations like this, but it doesn't really fit. It is always just, oh, here's a markdown with a screenshot. Well, it's 3 months later, how do I potentially replicate these queries? So now you have to copy and paste the queries and make sure they still work. Instead, with the Jupyter Notebooks, for example, you can just toss it in the code and then later on rerun it, and you can see, oh, I can reproduce it still, or no, this is actually how we solved the problem with the postmortem. So this is like a living postmortem. I like this example because you can actually do some really cool things with Jupyter. I don't want to talk too much about Jupyter here, but you can really explain a problem. So again, this is the idea, explicit is better than implicit. You can implicitly guess that a keyboard path when you're touch type or doing gesture typing will look a certain way, but it's much better when it's visual and it's explicit. So Jupyter was formerly known as IPython, and it also now supports R, Ruby, Haskell, Scala. So this means that this Python philosophy of essentially documenting everything, being explicit and purposely explaining everything so that everybody understands why certain solutions are a good idea or can reuse that, that kind of philosophy can be moved into other languages as well. So this is something I've been thinking about because Zynga, we use Ruby and Rails. It would be nice as part of a postmortem, for example, to just hit the database and grab a whole bunch of data and show, oh, this is this problem and this is how we solved it. And this is a nice chart showing, the average latency of whatever. So the next tool that I want to talk about is Sphinx. So Sphinx is a really popular Python documentation tool. If you've heard of the website Read the Docs, everything there is in Sphinx, and Sphinx produces really nice looking documentation. But the reason I think that Sphinx exists really is because Python itself has embedded documentation. So you have doc strings, and not everywhere, unfortunately, but in most places. So you have this ability to add this documentation, and it will be living or breathing. It will live alongside your code. As soon as the code is interpreted by the Python interpreter, it lives there. You can access it from anywhere. And this is very, very different compared to statically compiled languages, compared to Ruby, where Ruby still has, it's just the comments are all just stripped out. They just get skipped over, and nothing happens with the docs. But these embedded doc strings are potentially the most valuable way that you can explore an API. You can just go into any Python console, do help Django or help whatever. It doesn't matter which library. You can start walking through it and do it step by step. It'll list out attributes and everything else, and you can dig through it that way. And the only reason you can do that is because Python explicitly has this support. So that's kind of a language feature. It enables this philosophy of being able to explain essentially everything and whenever you want. You have this information always available to you. So here's an example which doesn't get used too often. The embedded doc string is used for tests. So doc test, the example from the Python documentation is a factorial, and you're just walking through different examples. When the input is XYZ, the output should be whatever. And when it has a certain value, it should output certain errors. And usually, I know in the Ruby docs, for me, I always just explicitly document it myself, but it's not the same as seeing an example that you can just copy and paste and run directly. So again, Sphinx, beautiful documentation by default. This ties into beautiful is better than ugly. So this is kind of a higher level view. This is not the code level view, but you can see that it looks much better, and I don't know, I feel like I'm more inclined to document code when I know that the output generated looks like this. When it looks like this, I can see something nice, and I can share it with my coworkers, I can share it with users, and they can be like, oh, I can use this documentation to set up Celery very easily, and it looks nice. It doesn't look like, oh, just a plain text document, for example. So Sphinx also has expanded to JavaScript. So Mozilla, who is also here, they have Sphinx JS, which can be used to parse JS doc, and it turns into a nice Sphinx document. So you have the ability to generate beautiful documentation from JavaScript as well. So that's another idea of this philosophy of documenting things, making it easier to explain things, is moving to other languages. And it's doing so through the tools. It's not doing it through, oh, I'm going to copy this one Python feature of embedded documentation. It's just using what's there, and it's turning nice, it's really nice documentation. And I've used JSDoc, and it was very not like this. You don't even get a search engine, no matter how primitive Sphinx is. So I think this kind of philosophy helps you to move towards explaining more of the code and being more explicit. So Python library API designs, I'm just going to skip over it quickly. You could see scikits and a little bit of pandas as well if you were sitting here for the last 20 minutes. I mean, if you've used Django and Flask and everything else, the API design makes sense somehow. I like this XKCD comic because you can import anti-gravity, and print hello world is just print hello world. There's no class to encapsulate it. There's no weird thing like Ruby where it's put s, and I understand, I guess that's put string, I guess. But in Python, if I import anti-gravity, I would expect, you know, anti-gravity.fly to work or anti-gravity.whatever to work. And I would also expect Jupyter Notebook to show me why it's working in such a way. And I would expect Sphinx documentation showing me the rest of the API as well. So there's like a lot of, the community itself builds these tools and builds this documentation, but it's the philosophy behind it that drives that urge and need to build this documentation and to build an API design in such a way that you can just go into the console and say, import anti-gravity, import Django, import whatever, and start working with it, start exploring it, start making something happen pretty much immediately. So I'm going to walk through a few examples of JavaScript. Not everybody can work with Python every day. I haven't worked with Python daily for quite a few years, but I still do a little bit of script writing here and there. I've worked more with JavaScript and Ruby now, but this is an example from Express.js, which is a web framework, and you can see they're kind of going in the direction of being a little bit more explicit. So they have the handle, and then they have a debug statement. So most libraries in JavaScript don't even have that debug statement. So you don't know where in the life cycle you are if you're trying to debug this. This one does. So that's kind of making it explicit that I'm at this stage in the life cycle. The function next is actually a helper method, which again in JavaScript you don't see too much of, even though the ability is there to have that. And they're very explicit in saying, oh, remove added slash, restore altered request URL. So they're labeling each section, and this is like a really tactical low-level code thing, but they're trying to be explicit in the way that they know how. So it can be argued that some of these points I'm making are kind of good generic software engineering principles. You should document things. You should use small functions and things like that. But in some cases, you can't really. Do you want to add another function to your multi-thousand line JavaScript file just to remove an added slash? Not really. And you know there's no module system, so do you want to try and shove it into a module system? And now there's a whole bunch of infrastructure that goes with that and so on. So Python has certain built-in language features, but these built-in language features get spread to other languages, and people try and make it work to some extent. Like I would expect in Python to see remove added slash as just another method call, restore altered request URL, it's another method call, and same with signal to exit router. It's just another method call with another class called router.signal perhaps, right? So just using the language itself, but the Zen of Python itself tells you to be explicit and to have these explanations and to talk about it and explain them and see if it is a good implementation or not. So in JavaScript as well, you kind of see the interactivity of it, which I mentioned with Python you have a lot of. So you can go to the console, explore an API, and just make something happen. Make something appear on the screen, whether it's just text or a chart or whatever. So in JavaScript land, of course, you have that with D3, and Khan Academy is really, really nice. You can type in a few lines of JavaScript, and now you can draw something on the screen immediately. So it's kind of trying to explain it a little bit more and trying to become, I guess, it's like Jupyter Notebooks. Jupyter Notebooks actually uses JavaScript to display charts and things and to be more explicit. So in the Ruby world, function call parameters. This was an interesting tactical code thing to look at because I have seen it where we pull out the parameters to a function into local variables. And when we do that, it makes it way easier to debug. You have all the values are already there. You can just toss in a bunch of print statements. You don't have to pull each parameter out and then examine it and put it back in and whatever. But if you use this pattern, you can just right away have ease of debugging. And this is something I've really only seen mostly in Python. I'm not sure how common it is for everybody else to have seen it, but I started seeing this in Ruby because some of my coworkers have used Python as well. So they started to think, oh, actually it would be nice to be able to see these values and to debug like this. So this actually came up a few days ago. I was fixing a bug, and it was testing method calls. And it was really, really, like, it's really dense, and you can't tell what parameter is which in the method call. You don't know what, like, you're looking at values, and then it starts, your eyes start to glaze over after, like, the second line, because everything looks kind of similar, you know, to 323 versus 324, and then what if you make a typo? Are you sure you made the right, you know, is your test actually correct, or did you just make a typo in the test rather than the code? So afterwards, what I did was I made it explicit. Each one of those lines turned into a very explicit, readable line. So it wasn't very beautiful, but it was very readable, and it was not sparse, but like very less dense, I think. So each call was, oh, here's this parameter, and it should be this value. The order of arguments doesn't matter anymore, which is really, really helpful. So you can put all the arguments that you care about testing right at the beginning or not. So it's just a little bit more readable, but this is something you can do in Ruby as well. You can do it in any language, but it's just more the mindset of, do you feel that this is a good choice? Because using that rspec helper to, is this list of method calls equal to this list that I'm expecting? That's fine too, and that totally works, but is that something that you really want to be looking at, you know, for the 100th time, like I have? Because this is actually similar to some of the code we have at work, and we do test method calls because it is quite important to do so for external APIs and all that. So in Ruby, we also have domain-specific languages. I just want to touch on this one quickly. Again, it's trying to make it, there is magic involved, but it does try to improve the explanation. So this is not explicit versus implicit. This is more about, is the explanation of my idea a good one? So in this case, it's just routes. So URLs have to point to a particular controller and action or function and be executed. So you have get hello points to the hello controller at index. Does this make sense? Yes. I'm taking A and I'm pointing it to B, and B should be executed. And it's the same with the rest here, and even the word as. So I have patch hello world to hello update as update hello world. So the as refers to this is a shortcut, this is an alias, right? So this DSL, this domain-specific language, makes sense, and it makes it easier for us to talk about this particular domain. So that's kind of, again, it hides some details, but it has that Python philosophy of explaining things, of explaining it and making sure it's readable and understandable, and we can talk about this idea and see, does it make sense? Does this implementation work? And the advantage here is if the underlying implementation does not work, we change that rather than this language we're talking in. So to recap the Python philosophy, the Zen of Python is the philosophy. It's expanded to other languages, JavaScript, Ruby, as I've shown here, Haskell, Scala, which I'm interested in seeing as well. And it affects the code that you write. So you change slightly, as much as you can, your code to fit this certain paradigm. And Jupyter does this brilliantly, where they've taken basically doc strings and doc tests and turned them into an interactive document, living document that you can see, and you can see the result of things, and you can see the explanation and why things were done in such a way. What was the intent behind the code? Which is something that we always skip over when writing code. It's, I know the intent today, but for myself in a month from now, do I know the intent anymore? Not really, because you have to dig through previous conversations, previous pull requests, and all that. Why not have a Jupyter notebook that has like that explicitness of this is the problem we were trying to solve, and this is how it looked like at that time, this is the solution and all that. And Sphinx documentation, again, it does the same thing, makes it easier to onboard people onto a team, makes it easier to see like good examples. You don't have to clutter your code with documentation, so that separation as well is a little bit nice to have. And I guess questions, comments? Oh, I'm not sure how the mic thing works. You just. Anyone with questions? Oh, okay. Sorry. Thank you.
Hi, thanks for the talk. I would have questions about what you said about Jupyter, but that might be too long, so I'll ask one about Sphinx.
Okay.
I found what you said really interesting, but I'm surprised because I would think Doxygen would be the language agnostic thing that pushed for standardization of these good practices. Yes.
So I actually did code in C and C++ long time ago, and Doxygen was, it's the first thing you see for most C++ libraries. But it didn't really migrate to other libraries, but you do have something like JavaDoc, right? Yeah. But
honestly, I know this mostly from the R world. So
okay.
Yeah, I really liked your presentation because in my experience, it's more like I transfer my philosophies between Python and R, but and I was not familiar with Ruby and JavaScript, not so much.
So on the Ruby side, I'm using RubyDoc or Yard, actually, or RDoc, and it's similar to Doxygen. It doesn't really, it has all these nice shortcuts and things, but I think Sphinx looks way better than Doxygen by default. So I think that for me, that's what kind of pushes it out to other languages. It just looks really good, and you kind of want to write more documentation because of it. Any other questions, comments?
If nobody else has a question, can I ask about Jupyter? Yeah, so I mean, I'm really glad that you're embracing the Jupyter culture, etc. I'm a scientist, so it comes more from this world, and it's not really built in that you would be explicit and give good explanations, but it's definitely the culture. But at some point, still, it's not like you're going to build a web app in Jupyter. So I mean, in a way, I found that you made a really good case for Jupyter, but at the same time, for most folks out here, I'm guessing, who are, you know, Python developers, do you mean that on top of writing their web app, they should have a Jupyter document on the side that documents the prototyping or explorations that they've made?
So I've actually done literate programming where you write a whole bunch of documentation and it's an explanation of the code, and then it takes all the code, tangles it up into whatever, some gigantic long file, Python file or whatever. And it's really tedious. In some cases, you don't need to explain everything because it is kind of implicit. You have this domain-specific language, you're all talking. You don't need to explain everything. And so for me, that literate programming experience for a web app, I definitely wouldn't do it, right? A Jupyter notebook for a web app doesn't really make sense. However, if your web app is living for many months, like at Zynga, some of the stuff is living for years and close to a decade. I won't lie, it's close to a decade for some of it. And you don't explain that original code because at the time you were focused on speed or whatever, or getting to market first, and you don't have time for that explanation. And you have a small team, you don't need to explain it to everybody. But later on, like I mentioned, postmortems, if something breaks, why did it break? And how do I explain it to the next person who comes along 5 years from now, why this particular part broke? And how did it look like back then? So Jupyter would be like a supplement. And the thing is, we already do this kind of data collection and gathering of explanations for postmortems, right? If you do postmortems, of course, right? So if you do them, you're already collecting this data. All you have to do is, first step, it's a markdown document. Next step, it's a Jupyter doc. So you're almost there, right?
Thank you very much.
Yep. And you can come down to the mic, I guess. Thank you.
Hi. Which passage or phrase in Zen of Python resonates with you most?
I don't know, I always keep turning back to like explicit is better than implicit, just because of that example in Ruby where you're explicitly listing method arguments. And that was something I had my head down in like for quite a few weeks worth of work. So for me, that resonates a lot because I mean, like here, I don't know the background of every audience member, so I have to be very explicit in some parts, and I can be implicit in others. So for me, that's kind of how much data do you share or hide and things like that. So for me, that resonates the most, though I do like beautiful is better than ugly, and I really think that one, especially for JavaScript documentation, the JS doc looks awful, terrible, and I can understand why nobody wants to write it, because the output is just not very good. But with Sphinx, the output looks pretty good. And I can make a PDF out of it. And oh, it's an EPUB, I can read it on my phone. That's actually not bad, you know? So it's a little bit better looking. So I think that one is also, those two are my favorites, I think. More questions? No more questions? Okay, awesome. Thanks.